Let me explain the purpose of today's seminar. In 2021, November 29th and 3rd December, we had two system failures. 29th of November, there was a partial failure in the power system, and 3rd of December, there was a total failure. After that, the Ministry of Power appointed an independent committee, expert committee, to investigate the reason for these two failures. The report and the finding of this committee is available in the CEB website. And also, as the transmission licensee or the operator, Ceylon Electricity Board has given their opinion about these two failures, which is also available in the CEB website. So the Ministry of Power has made a request to Institute of Engineers to share among the engineering community the findings of this committee and how we can avoid in this future. That's the purpose of today's seminar. With that note, I would like to invite Engineer Dr. Kamal Laksiri, the President of the Institute of Engineers Sri Lanka, to officially welcome you all.
Good evening to all of you. Of course, a small correction, I am the acting president. Yeah. Secretary and the senior officials of the Ministry of Power and Energy. I heard secretaries on the way. Officials of the Public Utilities Commission of Sri Lanka. In his absence, Dr. Abhesekara, General Manager, CEB, and all the additional general managers and senior officials of CEB, the officials from LECO, Lanka Electricity Company of Sri Lanka, Lanka Electricity Company. And I apologize for not identifying all of you individually. And all the members, council members, past presidents, members of IESL, and all the members joining in person, and we have about 50 members already joined online. And ladies and gentlemen, warm welcome again to this important event conducted by the Electrical and Electronics Engineering Sectional Committee of IESL. Chairman of the Electrical Committee, Engineer Kosal, already explained, but let me also repeat it. Now, we all remember, yeah, please go. The last year, we experienced, towards the end of last year, we experienced two failures. One in November, partial failure, and in December, a total system failure. And after that, the Ministry of Power, then it was Ministry of Power, appointed a committee to investigate the two incidents. And then the committee published a report titled Findings of the Committee, appointed to investigate power system failures on November 29, 2021 and December 3rd, 2021. So one of the recommendations in the committee report was to conduct a knowledge sharing session. I will quote the recommendation in the among the 10 recommendations. Recommendation number 10, publish this committee report on the websites of CEB and Ministry of Power immediately. Publish the CEB's response to the contents of the report within a month of releasing this report to the public. Conduct a seminar hosted by the Institution of Engineers Sri Lanka, IESL, with the participation of the committee members, Ministry of Power and CEB, to enable the knowledge sharing across the wider engineering community of the country. So as per this recommendation, a few weeks ago, we received the request from the Ministry of Power to conduct this event. And then IESL, we entrusted this work to our electrical arm, that is the Electrical and Electronic Engineering Sectional Committee, to conduct this event. That is how today it is happening. So first of all, I would like to thank the ministry for entrusting us this work as a professional body, we are very happy to engage in the national issues and also the important issues affecting the country. And please, I want to emphasize that this is a knowledge sharing session, not to find fault with anybody. And as the report recommends, to conduct an awareness program. And also, I hope we have veterans in the from the panel and the other members in the sector are joining today with us in this program. I am sure you will find it an interesting and fruitful event and will help to meet the objectives of the report. So with that, let me welcome you all again for this event. And I invite Engineer Kosala Kamburadini to proceed with the event today. Thank you.
Thank you, Engineer Dr. Laksiri. The ministry appointed committee comprised of 8 experienced professionals. Engineer Professor Dilantha Samaranayaka, Professor in Electrical and Electronics Engineering, Faculty of Engineering, University of Peradeniya, who was the chairman of the committee. Engineer Dr. Tilak Siambalapitiya, Managing Director, Resource Management Association Private Limited. Engineer Dr. M.N. Susantha Perra, Additional Secretary, Policy, Technical and Research, Ministry of Power. Mr. E.A. Ratnasila, Additional Director General, Department of National Planning. Mr. Sugat Dharmakirti, Additional Secretary, Ministry of Power. Mr. Nalindra Ilangakong, Vice Chairman, Ceylon Electricity Board. Engineer Andrew Naumuni, Additional General Manager, Generation, Ceylon Electricity Board. Ms. Indika Ranatunga, Senior Assistant Secretary, Ministry of Power, convener of the committee. I would like to invite Professor Dilantha Samaranayaka, the chairman of the ministry appointed committee, to briefly take you through the findings of the report prepared by them. Over to you, Professor.
Okay, good evening to all of you. I hope the gentlemen online could hear me and also see the screen. First, let me thank the IESL for giving us this opportunity to present this knowledge sharing session with you as per the 10th recommendation of the committee report. Now in this, the incidents 29th November and also 3rd December, we have submitted the report on the 21st of February this year. Members, as was mentioned earlier, were myself, Dr. Siambalapitiya, Dr. Susantha Perera. Both of Dr. Siambalapitiya is online connected, I think, and Dr. Susantha Perera is here, and few other members, Mr. Andrew Naumuni from CEB is here, and Ms. Indika Ranatunga is also here with us today. And the TOR of the committee was to identify the reasons for the power failure and review the study reports. Similar incidents occurred in the past. So under that, we took the 2015, 2016, 2 in 2020. So altogether 4, and then make recommendations for remedial measures that need to be taken by the CEB to prevent such incidents in the future, which is the most important thing. And also investigate whether this is an incident which could have been pre-planned or which could have been avoided. So that is also something which took time for us to investigate and produce the final report. Somehow, I think we managed to deliver the report in a reasonable time compared to the time taken by the previous reports. So in the final report, we presented the investigation on the power system failure on the 3rd December mainly, and covers the partial system failure on the 29th as well. So our main focus was on the incident took place on the 3rd December, because that was a total system failure. And then the findings presented in the report are purely based on scientific merit of the data. So I specifically told in the meetings with the CEB also, we entertain only the scientific data available in the machines or relays or whatever. And the conclusions were based on that. And the report consisted of 86 pages in the main body and 260 pages in the annexes, so altogether 346 pages. And it is available, it has been made available in the CEB website, and I am sure Ministry of Power will take actions to put it in their website as well. And similarly, my colleagues in the CEB, in the next presentation, they will show you the same thing is the response to the report is also available in the same web space. Right. So let me take you through the incident took place on the 3rd December. This is the Sri Lankan transmission network that you can see, and my focus is in this particular area because most of the things happened in that. And the pre-fault conditions system was operating normally on Hydromax mode, where the hydro generation was around 1,200 megawatts and the demand was 1,875. CEP colleagues can correct later if the numbers are slightly different. And this was the case by 11:27 and 14 seconds on the 3rd December. And the double circuit 220 kV Kothmale-Biyagama transmission line was carrying approximately 650 megawatts, which shows in this diagram here. Sorry. Right. Let me use the. Oops. Anyway, is there a point? Okay, fine. Yeah, I think you can follow it. Just the line locations are given here. And then this is this 650 turns out to be 750 amperes in terms of current. And this was the pre-fault condition. And suddenly in the circuit two, there are two circuits, a double circuit line, as majority of you know. And suddenly at 11:27, 14 seconds, we could see in the fault recorder diagrams that there's a neutral current increase and phase B current decreasing, which is typical to a high impedance earth fault. And it was located 24.1 kilometers from Biyagama end at the 138, near 138 tower in the line. From CEB side, we got to know that it could probably due to a fire lit up to burn garden refuse. But still, the reason is, whether this is the exact cause is not known. This is some evidence that we got. So with that, what happened was immediately the differential protection operated and isolated that fault. And what happened next was in 288 milliseconds later, the complete line, circuit 2, disconnected by the operation of N-fault protection, right? Typically, the protection manual says that the N-fault protection operates for short circuit between circuit breaker and the transformer. So this is some other phenomenon which took place in that during that time. And with that, the current in the circuit 1 increased to 1,300 amperes, still within the limits because the line is, the circuit is rated to 1,500 amperes. So under, with circuit 2 lost, still the system continued after some transient. Then, of course, the auto reclosure of the circuit 2 happened, but the only thing is because of the end-fault operation, end-fault protection took place previously, the Kothmale end, thank you. The Kothmale end is already circuit breaker lockout. So therefore, this side did not reclose, only this Biagama side reclosed. So effectively, because of other breakers are also open, the circuit 2 was not usable. And then another incident took place after about 22.33 seconds. That is, sorry, before that, so with this condition, we could see that the system operated with N-1 reliability, see, with one circuit in place, right? Then another incident took place in the other circuit, which is in the circuit 1. That is when the phase P was went off, the neutral current increased, and that had been picked up by earth fault protection. And 22.33 seconds later, circuit 1 also turned off. And but nevertheless, we could see in the various waveforms and data provided after 288 milliseconds, where the neutral current went down to 64.5, which is below the 80 ampere threshold. So there's a question as to why this earth fault protection operated when the current is below the threshold. So, and we found that this is our committee's finding, and CB may have different opinions on that. We found that the reset setting of the relay has been erroneous. We will come to the details in a while. That is what we felt as the committee. And so these are the main two events which triggered the whole failure on the 3rd of December. Now, first thing, circuit 1 on the Kothmale-Biagama, circuit 2 on the Kothmale-Biagama transmission line, and then circuit 1 on the same line. And once that happened, the current, which was 750 each previously, had become 0, and that path is no more available. And the only route to for the power to flow in a hydromax scenario is to go through via Kothmale, New Anuradhapura, and that side. On that particular day, in that double circuit, 170 kilometer long double circuit, circuit 1 was out for some other project work. So only circuit 2 was there. I will come to that towards the end. Then if I summarize the sequence of events, the suspected earth fault on the Kothmale-Biagama circuit 2, then circuit 2 phase B opened on both ends by the differential protection, which I take as the 0 millisecond. Then end-fault protection unexpectedly causing circuit 2 to be totally tripped and locked out from the Kothmale end. And then simultaneously the load on circuit 2 transferred to circuit 1, and the system achieved stability nearly in 288 milliseconds. This is exactly the time at which the neutral current has come down in the other line. And then the Kothmale-Biagama circuit 2 phase B auto reclosure operated after this less than 1 second time. Then in about after 22.33 seconds, the circuit 1 tripped. And after that, as you may understand, there's no, limited path for the power to flow. The generator started tripping. Victoria Generator Unit 1 and 2. Then Lakvijay Power Plant Unit 3. Unit 2 was not functioning at that time. And then New Anuradhapura Circuit 1 to LVPP tripped, and then Kothmale Generator trips. Then the Lakvijay Unit 1 tripped, and Lakvijay New Chilau Circuit 1 tripped, and Kothmale New Anuradhapura Circuit 2 tripped, which had power swings, unstable transient power swings, which I think CB presentation will cover. And then Victoria Generator Unit 3 tripped, and Kothmale, Upper Kothmale Hydropower Station Generator 1 tripped, and the complete collapse in 34 seconds. So this is the total scenario. This is the timeline, and these are the main contributors. This is how things progressed in the incident. So the whole thing, it took only 34 minutes to do this, to happen. Now, after going through the various reports from the CEB and also our visits to various places relevant, this is what we concluded in the report. The primary cause for the fault that subsequently initiated several events, finally leading to the total power failure, has not been established, because we can see that it is the cause may be on the primary side, but the exact cause, how it happened, why this earth fault happened, is not known. Then the line protection operated correctly, that is, it was trying to reclose, but by the time it reclosed, the end-fault protection had operated with circuit breaker lockout. So you can't do anything beyond that point. So that is how the circuit 2 became unavailable. Then, and when we looked into the history, we got a similar case where this end-fault protection operation on the 21st of May 2021 in the same line, and also on the 29th November, similar incident had taken place. Now, our observation is that if this was investigated previously when the incident took place, probably this could have been avoided if it happened due to any wiring error or some other problem in the maintenance. So which could have been avoided, but unfortunately it did not happen. And then one other thing that we could observe is that once the circuit 2 is gone, what is remaining is circuit 1, and our load flow studies also showed that if we had the circuit 1 in the healthy condition, we could survive the system without collapse. And when we went through the details of the relay settings, etc., we found that because this is somewhat unusual, it operated after 22.33 seconds from the initial high impedance earth fault or whatever the earth fault on the circuit 2. So, so what we felt was corresponding to the neutral current rise, right? The relay may have picked up the earth fault, but that high current came below the threshold level after 288 milliseconds. Because of the reset settings were configured to disk emulation, it didn't react instantaneously. So our conclusion is that it could have been avoided. Of course, this may have to be trialed if this was set to instantaneous. One other reason why we are saying so confidently is that Biagama end, it is in the instantaneous reset. And and one other thing which we found in the when we analyze the records is that now protection for these lines, I think the other lines as well, have been provided by two sets for safety and reliability. And in all these cases, main one has operated and things have triggered from main one. In the very first incident, main 1 and 2 both have operated parallel. And when we went through the main 1 records, there's nothing suspicious, but main 2, we found some access. So we were trying to get use a level 1 access, which we found at 8:33. And we did not, as the committee, we did not get the response by the time we submitted the final report. But one day after submitting the final report, we got it. And to me personally, we did not discuss that in the committee. To me personally, it was convincing. So therefore, I don't think this has happened. And the OEM has given us some explanations into this one, but we need to discuss that at another forum. So continuing with the conclusions, the other thing is, once the circuit 1 and 2 are gone, the power flow that took place, the only rescue path was via the Kothmale New Anuradhapura line, where there was only one circuit, and we could see very high currents, like current reaching 2,400 amperes and coming back with the current maximum, voltage minimums, and voltage maximum, current minimum, which is power swing. And that was a transient unstable power swing. I think CB will show you the details. So this was there. And finally, that line also got tripped by the operation of the distance protection. And when this took place, we have to look at we looked at the other giant who is standing there in Puttalam, that is the Lakvijaya power plant. When the total blackout took place, the restoration of the auxiliary power to Lakvijaya power plant has taken about 2 hours and 30 minutes, which was too long for it to survive. The recommended time period is you can go into fast cutback mode for 30 minutes, but not for 2.5 hours for sure. But in the investigations, we found some records that the CB teams have tried before to get this auxiliary power from Upper Kothmale, and New Anuradhapura to Lakvijaya. They had only done once, and that single trial had taken 1 hour and 40 minutes. So in our recommendations, we have given something relevant to that as well. And once the system collapsed, the National System Control Center has done a good job in trying to bring the system back by parallel operation, Mahavali, Lakshavan, and Samalavawa, and ultimately they have managed to restore the transmission network in 5 hours and 15 minutes, which is 1 hour gain as compared to the blackout on the 17th August 2020. So these are the conclusions, and based on that, we made some recommendations. The first one is now this is somewhat very strict kind of recommendation. Why we went for that is now in this particular incident, non-persisting earth faults are typical in a power system. That's fine. And then plus there's an end-fault protection operation. That is also fine as far as you know the reason, but in this case, technical problems associated with this. But anyway, the end-fault protection took place. So we were not sure whether now accidentally the earth fault took place and the end fault operated. If somebody knew that, okay, this logic I can trigger the enfold if I create a earth fault. That's there. So we wanted to make sure and clear CB that it is not the case or it is the case, whatever it is. So we made the first recommendation. And also looking at the financial losses, we want the CB and the authorities to expedite the procurement of an auxiliary power supply solution for the Lakvijay. In the reports, we found there are 11 options studied and one has been recommended. And whether that one or any other new recommendation, whatever it is, it's mandatory that auxiliary power is made available for Lakvijay power plant in this to stop it getting emergency shutdown or unsafe shutdowns. And then our load flow studies reveal that in this scenario, when Kothmale-Begama circuit 1 and 2 both are gone, even the new Anuradhapura circuit 1 and 2 could not have saved in this particular scenario. However, if we had commissioned Kothmale, New Polpitiya and Padukka Panipitiya 220 kV line, and if that was available, then the system could have been saved. But unfortunately, when the incident took place, that line was not available. I don't know whether that is there now. And in the restoration, though I said that the system control managed to restore the network back in 5 hours and 15 minutes, we could observe there are mainly there were 9 points where there were delays. For example, in Kothmale, if I remember correctly, the delay was around 2 hours. There was a pressure relief valve operation, and then the fault, alarms coming, some error message coming, which was not displayed to the operator, and so on and so forth. There was several incidents like that on both circuits 1 and 2, and also in Samanalawa there was a delay, and then the New Lakshapana there was a delay. Likewise, there were 9 delays, and these were the identified ones. We would like the CEB to look into that. And then also we found that there were some ambiguities. One was that reset settings dissimulation versus instantaneous. Likewise, we found that some of the overcurrent settings were also contradictory in the 2 ends of the line, which is not possible. So we wanted to have a revision on that. And also we recommend to conduct regular inspection of functioning of the auxiliary circuits of CEB, circuit breakers, because the enfold operation, when the committee made several requests, the CEB also, I think, they had their own investigations anyway, and they found that the implementation of the logic, relay logic, had problems. Because in the documentation, what we found is normally closed series connected auxiliary connection, whereas what existed was normally open parallel connected logic implementations, and they were also not identical on the circuit 1 and circuit 2. So that is somewhat questionable. And then the 7th recommendation, expedite the process of synchronizing disturbance fault recorders. Now, this issue has been there even in the previous committees. We have made recommendations into that one, because no point in having DFRs if their clocks are not synchronized. One can argue, of course, we can do it manually, but I don't think that we can reach the time resolution required to do a deep analysis unless you have synchronized. Then post-analysis process of the operations of assets, generators, transformers, transmission lines, and their protection systems, etc. We recommend to strengthen that procedure. And also the models, which is another thing which we have been telling for a couple of times, that is the transient models that you have, they should be up to date with the whatever the network expansions taking place. And the last recommendation is the implementation, that is it's being implemented right now, the seminar. And we want to disseminate this knowledge and give the true picture to the public, which is very important. Otherwise, it's not good for the utility. It's not good for the rest of the authorities and whoever is responsible. We have to reveal our findings. This is to share our knowledge and share the findings. And in addition, we went, one of our TORs was to look into the recommendations made by previous committees. And we took, we went through, as I told at the beginning, 2015, 2016, February 2020 and August 2020, all 4 reports, and we took 3 major recommendations. That is, number 1 is implementing the 20-year least cost long-term generation expansion plan, 10-year transmission network expansion plan, and 5-year distribution development plan without delays. This is mandatory, especially the first one, long-term generation expansion plan, because on 17th August 2020, we clearly saw that the system doesn't have that much of inertia. Some of the members are already in the forum, in that committee. They also will agree with me. System doesn't have that much of inertia to withstand disturbances. And also the other thing. Then the other recommendation is Ministry of Power, Public Utilities Commission of Sri Lanka and CEB may take actions to conduct independent dispatch audits through competent external parties, perhaps jointly with the government audit, to enhance the transparency of the process. This is stemmed from the blackout on the 3rd February 2020. And also, it is highly recommended to prioritize various developments proposed by different divisions based on the resource availability. So these were the continuation of recommendations from the previous committee, and the 10 recommendations were the recommendations by the present committee. And this is what I have to share with this audience, both physically and online. Thank you very much for listening. Thank you.
Thank you, Professor Samaranayaka. Now we need to listen to the transmission licensee, Ceylon Electricity Board. Present their response to the findings of the committee and also how to avoid or mitigate this type of incidents in future. I would like to invite Engineer N.S. Vettasinghe, Deputy General Manager, Controls and Protection, Transmission Division, Ceylon Electricity Board, and Engineer Eranga Kudaheva, Chief Engineer, System Operations, System Control Branch, Ceylon Electricity Board, on behalf of the Ceylon Electricity Board.
Thank you. First of all, good evening, all of you. I'm Eranga Kudaheva, Chief Engineer, System Control, Ceylon Electricity Board. Myself and Engineer Vettasinghe from Deputy General Manager, Control and Protection Branch will present the technical related things and analytical part that we have done related to the total system failure occurred on 3rd December 2021. So, first of all, I will briefly explain the pre-fault situation and of the system and what has happened during the fault. Then Engineer Vettasinghe will carry out the analytical part that we have done, followed by myself again, the restoration process. Due to the time constraints, I will just brief through the presentation. First things, the content as follows. It's discussed about the overview of the present power sector and the power flow to the before the failure, and basically it's the snapshot of the system and the cause of the failure and response of the protection scheme, then restoration process. Okay. This is an overview of our system. I'm not much going to describe these things. Just What I'm going to highlight is our system frequency is 50 Hertz, and it says this information for the rest of the people who are outside from the CEB, I mean, maybe electrical and maybe civil and other disciplines as well. In our system, usually a single generator controls the frequency, and that plant is responsible for the maintain the frequency at 50 Hertz. And apart from that, other generators which is running on the system, running in free government mode, we can say they are support for the system frequency changes, their response for the changes. That's how we operate the system to maintain the stability. Right? That have to be keep in mind when we're discussing about the total system failures. And we operate our transmission voltage 220 kV and 132 kV. So this just some information related to our installed capacities and energy mix in 2021 and renewable energy share. Okay. Okay. So the operation policy, how we operate our system, the transmission network. This is the geographical map, how the transmission lines are located throughout the country. And when we operate the system, we maintain the N-1 contingency criteria as much as possible. Why I said as much as possible, there are some transmission lines we cannot maintain N-1 contingency, but we try to maintain that as much as possible. At the same time, we limit a single unit loading to 25% of the total generation. This policy is basically related to the reliability aspects. Then the general policy and the priority of the system operation. So when we operate the system, we ensure the safety of persons, the protection of equipments, then the availability of supply, then quality of supply, then finally comes economy of supply. Now, based on the current situation, we have to look into those things. Okay. So this is the simplified version of the whole transmission network. The all transmission lines and substations are not depicted here. Just to understand. This is the Mahaveli complex, and where we have Mahaveli generations. The most of the power generated by that transferred to the Biyagama. We have Kothmale Biyagama, and we have Lakshapana complex. That power comes to the load center via Posgama Aturugiriya lines, and we have Samanalavawa located in the southern part of the transmission network, and Lakvijaya power plant. From Lakvijaya to Biyagama, there are several substations and transmission lines. This is the transmission network. We have some critical transmission lines because we have to keep these things in mind. So when we run the maximum Mahaveli complex, when we run at maximum level, then Kothmale Biyagama line becomes critical. So when we operate maximum Lakshapana generation, then transmission lines Lakshapana, Polpitiya to Posgama Sitaga, that lines become critical. So when coal plant is running at 900 megawatt, the Lakvijaya to Nuchilau. And when we run the thermal maximum, most of the thermal power plants are located western part of the country, the Kalanitissa, Kerawalapitiya, Power Barge, all those plants are here. Then this Kalanias, Kolonnava, and Kolonnava to this transmission lines become the critical transmission lines of the network, because the reliability of the transmission system depends on the loading of these lines, definitely. So any of this failure of any of these circuits may cause another failure, maybe today, maybe tomorrow. So I just take a few more time to explain what is how the total system failure going to be happen. So there are failures, we can categorize partial failures, major failures, and total system failures, which happened on 29th November. It's a major failure, which affects around 5 to 6 substations. Partial failures mean it affects more than 1 to 2 substations, as well as some 30K feeders may can trip. The total failure is an entire system collapse. So how it happens? Actually, total system failure, no power in the grid. So we have to have a severe fault, then responding to them that a generator can trip. Definitely when the generation trips, system frequency drops. When it further drops, when it reaches to the under frequency trip settings or protection settings of the generators, they will trip as a cascading event, and ultimately no power in the grid. So I'll use some small animation to show this to the people who have don't much understand about the power systems. When the system is in steady state condition, generation demand is balanced, system frequency remains at 50 Hertz. So what happens when single generator trips? We lost a single generator. So what happens? System frequency goes down based on this balance. If frequency further drops, when it reaches to the 47 or the protection settings of the other generators, protection activated in that generators and other generations also trip as a cascade event. So no power in the grid, it's complete blackout. Right. So what happens on 2020? There is a reason. The reason is there is a three-phase earth fault in the Keravalapitia, severe fault. That is the reason, and generator trips. That 810 megawatt loss from the system, so system fails. At that time, total generation loss is 40%. In 2021, the fault in the transmission network, consequently, generators are tripped, 712 megawatt from the Mahaveli, and at the same time, not at the same time, after some seconds, Lakvijay tripped, rejecting 540. So altogether, around 50 to 60% generation loss, we cannot recover the system. Because our system is very small, so our system inertia is small when it comes in general terms. I mean, our system is not much strength. We cannot say exactly weak, but it's not much strength. So we cannot sustain that much of generation loss to our system. Okay, now, so this is the load curve. This brown color one is the solid load curve, which is on 2nd December 2021. So this one is 3rd December. What has happened? 11/27 total failure occurs. That's the total failure. So electricity consumption becomes 0. After some time, it starts restored. And again, it comes to the load at the say previous day, somewhere around 18, 15 like that. So this green color load curve shows the partial failure, which has happened on 29th November, 1930. So it's a partial failure. Why a small load has been reduced, removed from the system, the unserved energy is less. Right? So this is a difference, how it affects the system in case of partial failure, in case of total system failure. So this is a snapshot of the system just before the total system failure. Mahaveli generation is running at 712 megawatt. The loading of Kotmale Biyagama 2 circuits is 745 into 2. One Kotmale to Anuradhapura 220 kV circuit number 1 is out of service at that time because that one line has been released for the project called New Habarana grid integration purposes. So Lakvijay is running at 540 megawatt. Since that time was we are running hydro maximum condition, Lakshapan also running 315 megawatt. So what happened at that time? Total generation was 1,956 megawatt. Mahaveli has 36% and Lakvijay has 41%, altogether around 77%. So what happens? Single circuit tripped. Then that load transferred to the circuit number 2, that is 1,375 amperes. It is, so the overcurrent setting of this circuit is 1,500. So which it is less than 1,300, we maintained N-1 contingency criteria even under hydro Mahaveli maximum condition. So it's, at that time also system is stable because it's running healthy, even it's reached to maximum limit, but running system is healthy. But after some time at 11:27, 35 seconds, that line also tripped due to the activation of protection. Then that power, which is flowing from here to here around 560 megawatt, all transferred to the most 99% of power transferred to the remaining circuit from Kotmale to Anuradhapura. It don't go there, it transferred to this line. So what we have experienced, we have never experienced that one. That power, the severe active power oscillation was observed in Kotmale New Anuradhapura 220 kV line, severe active power oscillation. At the same time, we observed over frequency condition in the Kotmale, because it loses 720 megawatt of generation. I mean, there's no path to deliver the 720 megawatt of generation. So that bus experience over frequency condition. At the same time, remaining part of the system losses 720 megawatt. So that part experience under frequency condition, the frequency drops. So similarly, in this line, this side experience over frequency condition, this side experience under frequency condition, we have never experienced that in early. So that graphical representation. So at this time, Kotmale Begum circuit 2 trips. So frequency increases. Red curve shows the frequency of Kotmale. This blue curve shows the frequency of Anuradhapura or rest of the grid. You can see Begum, whatever. So this is the active power fluctuation occurred in the Kotmale Anuradhapura circuit. So after that, this main system collapse. So after the line 2 trips, after some 6 or 7 seconds, around 6 seconds, system collapse. System collapse in all the generators trip due to the activation of their protection scheme. Okay, so that's the pre-fault condition and how the system trips of total failure occurred. So let me invite Engineer with Singha to explain the what happens in the protection scheme. Finally, I'll be doing again registration part.
Good evening. I'm NS Singha, Deputy General Manager, Control and Protection. I'll be explaining the operation of protection relays, mainly in Begum Kotmale line, and how it affected this occurrence of this total failure. First. First, I will explain the operation of relays in Begum Kotmale 220 kV line 1 and 2. So what you have first observed is in line 2, there was a earth fault current from B phase to ground as per records available from protection relays as well as digital disturbance recorders. So because of this B phase to earth fault occurring in this line 2, differential relays installed and both ends of the line have detected that fault and tripped that particular phase of that line and isolated the faulty condition from the network. So simultaneously, the auto reclosers of the line started their process, and around after about 0.8 seconds, those auto reclosers supposed to close the line. But before that, what was happened was that there was a intertrip signal from Begum end to the Kotmale end, and lockout relays at Kotmale end was operated in this line too. And that for that reason, from Kotmale end, the auto reclosing process could not continue and stopped at that point. However, from Begum end, the line was auto reclosed after about 0.9 seconds. So anyhow, the power flow through the line 2 could not continue anymore because of the permanent tripping from Kotmale end. So after tripping of this line 2, what happened was the line 1 got the full load current between Kotmale and Begum, and it was moved about 1,400 or 1,500 amperes like that. So with this higher load current in the line 1, what we have observed is there was a permanent zero sequence current in the network, and that permanent zero sequence current became above the threshold of the backup earth fault protection setting. That means the setting is about 80 amperes and the permanent, initially because of the auto-reclosing process of the single phase in the parallel line, the high single phase current was observed in line 1. And because of that reason, relay got picked up. But after that, what happened was that this permanent neutral unbalanced current in this transmission network, the earth fault relay could not reset to the reset. And because of that reason, after about 22 seconds, relay got operated and tripped that line as well. So next, I will discuss the tripping of this Kothmale Nuwan-Radhapura line. So in the Nuwan-Radhapura Kothmale double circuit line, one line was taken out for project work, and only line 2 was available at that total failure day. And after tripping of the Kothmale Biyagama line 1 and 2, all the power from Mahaveli power plants to the rest of the network went through this line 2, and severe oscillations were observed in that line, frequency of power oscillations. And in that process, the distance relays, maybe what we have observed from the digital disturbance record is the low voltage level and high current level, and distance relay operated because of that low voltage and high current situation. So this is the summary of the indications that we have noted out of the protection relays in Biyagama Kothmale line 1 and 2 and Kothmale Nuwan-Radhapura line. This is a summarized form in a table format. So I will here just explain show the digital disturbance records that we have taken from the recorders. So this is the digital disturbance record of the Biyagama Kothmale line 2, and in this portion it shows the slowly increasing neutral current. That is what we say is there was a small phase to ground earth fault, and in same instant there is a small decrease in the blue phase phase current. So that's we interpreted as the earth high impedance transient earth fault in this line. A similar record we found from the protection relay as well. This is from the digital disturbance record, digital disturbance record. So after about so initially B phase current, other than the B phase, other two phases current flows as earlier, what had happened earlier. But after about 280 milliseconds, the line got tripped from Kothmale end, and transfer of power stops at that point. However, after about 0.89 seconds, from Biyagama end, the line got auto-reclosed and Biyagama end breaker closed. This is the digital disturbance record, snapshot of digital disturbance record obtained from the Kothmale end of line 1. So in this line, what happened was the backup earth fault protection relay operated. So backup earth fault protection initially got a high startup current because of auto-reclosing process happened in the parallel line. So that time the neutral current was about 400 amperes. After that, there is a persistent high neutral current because of some unbalance in the transmission network. So it is around 65 amperes throughout this process. So because of that high unbalanced current, relay operated after about around 10 to 2 seconds. This is the snapshot taken from the Bain records between line current waveform of line Kothmale to Nuwan-Radhapura. So these are the power oscillations observed in the digital disturbance record in this particular line. So current waveform increases, it's like a like this about 5 seconds. After that, there's some steady area, but at the end, distance relay is stripped in this point. But by that time, almost all the system power generators have been collapsed, and this tripping is not a contributory factor for total failure, because by this time, all the generators have tripped. So here, in this slide, I will be explaining the tripping of Biagama-Kothmale line 2 by differential protection relays. First, the Biagama-Kothmale line 2 tripped from both ends by the operation of line differential protection due to transient high resistant earth fault. The information recorded in relays and digital disturbance recorders installed at Biagama grid substation and Kothmale power station are sufficient to prove that there was an actual primary earth fault. That's our observation when we analyze the events and records collected from relays and digital disturbance records. So when analyzing the past trippings of 132 kV and 220 kV lines, it was found that most of the time, around 95% of the time, physical evidence for primary cause of the fault is not found. Because only when we analyze the past failures, around 5% of the time, only we have been able to find some cause for that particular tripping, and our maintenance staff has to go to those locations and rectify that issue. Other than that, 95% of the time, the line faults recover themselves without any human intervention. As per explanation given above, it can be concluded tripping of Biagama-Kothmale line 2 is due to an actual transient high resistant phase to ground fault. This is natural phenomena that can occur in high voltage overhead transmission lines. Hence, possibility of sabotage can be ruled out. That's our final remark on this particular tripping of this particular line. Then in this slide, I will explain tripping of Biagama-Kothmale line 1 by earth fault protection. Biagama-Kothmale line 1 tripped by the operation of non-directional earth fault protection function of main 1 protection relay. Earth fault protection setting adapted in main 1 protection relay is as follows. Current setting, what we have adapted in this particular line is 80 amperes. As per 80 ampere current pickup, the 80 ampere current setting of the earth fault protection function, it relay picks up when the current goes about 110% of the setting, that means 88 amperes. And again, relay reset when the current goes below 58 amperes. So when we analyze the relay manual and how relay behaves, we found that when we set the small values of current in this particular relay, it keeps about 30 ampere difference between pickup and reset. In secondary terms, it's about 15 milliampere. So time multiplier settings adapted in this particular situation is 0.38, and curve used is IEC normal inverse. So as per measurements done by control and protection branch, the average zero sequence current of Biagama-Kothmale line is about 5% relative to its load current. So before this total failure, we have also not measured this permanent zero sequence current, and we were unaware of this high unbalanced current in the line. But after the total failure, we went to the mainly almost all the important lines. We went there and measured the zero sequence current, and in this particular Biagama-Kothmale line 1, it was found that the unbalanced current is about 5% of the load current. So when the current goes up to about 1,500 amperes, around 75 amperes, we get the unbalanced current. So after that, CB staff tested the performance of earth fault protection function and confirmed the following by simulating the zero sequence current observed during the total failure day using the Omicron test set. So relay operating time is around 22 seconds. Relay pickup threshold is 88 ampere when pickup current is set for 80 amperes. Relay drop-off current is 58 ampere when the pickup current is set for 80 amperes. That is what we say is what we have observed theoretically. We have proven it by just injecting the current of this particular relay model. Further, it was confirmed that about test results do not change whether the relay reset characteristic is set for instantaneous reset characteristics or distimulation reset characteristics. Because in the manual, it says different things, but actually when we inject the current and check the test the relays, relay behavior does not change whether you set the relay reset characteristics, whether it is instantaneous or discoverable. It relay behaves same way. As per explanation above, it can be concluded relay has operated correctly on the total failure day. Current pickup setting adapted for the earth fault protection function is too sensitive due to persistent high zero sequence current in the network. That's the main conclusion that we derived out of this tripping of this line, that we can't work with this 80 ampere current pickup setting. So end fault protection scheme. So end fault protection scheme is that at Biagam the grid substation, the end fault protection scheme of Siemens make is used to detect the faults occurring in between the circuit breaker and current transformer in line base, which are not isolated by the main protection relays. The end fault protection will be active only when the current through the CT is more than the breaker failure end fault protection current setting. The end fault protection is an inbuilt function of the busbar protection relay, and for proper operation of this function, the busbar protection relay shall receive the accurate circuit breaker status information. So control and protection staff found that control panel protection panel is not receiving the accurate circuit breaker status information, and in turn the end fault protection scheme is not receiving the accurate circuit breaker status information. This has resulted the unintended operation of end fault protection, which send an intertrip signal to remote 10, preventing auto recrossing at Kotmale end. While analyzing the failure occurred on 2021-11-29, control and protection staff identified the presence of an unintended intertrip signal in Biagam Kotmale lines. However, before carrying out the corrective action, failure on 2021-12-03 occurred. So what we say here is that on the 29th incident as well, this end fault protection intertrip happened, but we could not analyze it and corrective measures could not carry out before the third failure. So another thing that in this slide that we want to explain is that after the total failure, there was a lot of discussion that these relays have been ad hoc accessed in an ad hoc manner or something like that. So that was initiated because we shared some event list in the relays to the investigation committee. Anyhow, that information went to the social media as well as, and they have copied this information and shared in that the social media that these relays have been accessed in ad hoc manner. So because of this reason, we forward this information to the relay manufacturer and ask, can they explain why in this, what is there is we have not logout events within 1 minute in 7 logout events in within 1 minute time period. So this has happened in the early morning of the total failure day. That means around 8:33 hours in the total failure day. So that's a very critical issue. So because of that reason, we referred this information to the relay manufacturer Schneider Electric and asked their explanation. So they went through all our information, what we have submitted, events list and setting files, and finally they gave a conclusion that there was no actual logging in attempt. So what we have received from them is that control room operator has tried to erase, he wants to erase some LED indications come up on the relay. He wants to erase it. For that process, he has tried to press the clear button, and he has pressed the clear button while the relay menu is on in the password selection menu. This is how relay manufacturer has explained. The main two Schneider protection relay have not operated during this failure. That is also important thing because there was a discussion, there was some comment that main 2 has operated, but in this particular line tripping, main 2 relay has never operated, only main 1 relay has operated. So even somebody has accessed this relay has never tripped the line. And it was found that no one had accessed this relay at the mentioned time on 2021-12/3 using the password. The event user logout on user interface level 1 correspond to pressing clear button on relay to clear relay LED indications. The CRO had pressed clear key from the HMI of the relay 7 times within 1 minute period when HMI was at password selection option window of the system data menu. That's the summarized information we received from OEM. This event has been confirmed by recreating using relay of similar model by the staff of protection system. So we actually, after that, because after obtaining the clarification from OEM, our staff also have been able to recreate this event and see that it's actually happening like this. The CEB responses for conclusions and recommendations of the committee report. This slide explained about our final recommendation. CEB responses for conclusion and recommendations of committee report is made available in CEB website and can be accessed using the following URL. So this CEB website URL that anyone can go there and see our responses for committee report, committee recommendation, and committee conclusions. And if I go to the location, you can just have a look. I think that web address is not working at the moment. Okay, then I'll go to. CB response for conclusion and recommendation of committee report is available in the following location. Summary of operational protection schemes and remedial action taken by CEB. Kotmale Biagama 220K line 2 has tripped by the operation of line differential protection due to high resistance earth fault involved in the phase B of the transition line. After the fault is cleared, the circuit breaker at Biagama in auto-reclose and circuit breaker at Kotmale received a direct interrupt signal and resulted in a 3-phase trip. Kotmale Biagama 220K line 1 has tripped due to the operation of non-directional earth fault protection with the increase in persistent zero sequence current after tripping of the parallel line. It was apparent that the existing non-directional earth fault setting 80 ampere in main 1 relay was not adequate, and hence the setting was increased to 160 ampere in line with the main 2 setting of Biagama Kotmale line. That's the one activity carried out by the control and protection staff who not to reoccur this backup protection relay operation of Kotmale Biagama lines. So error in single phase circuit breaker status in Kotmale line at Biagama was corrected. This is to avoid incorrect operation of end fault protection scheme. We have done this status circuit breaker status proper wiring of the circuit breaker status to the protection busbar protection relay of the Biagama. Also, protection relays, protection schemes were tested and settings were reviewed in Biagama Kotmale line by control and protection branch staff. Again, final recommendation recommended to review the protection scheme, protection setting of transmission network by an external expert consultant. So So thank you very much for listening to my presentations. So from this point onward, our engineer Ranga will continue.
Okay, thank you. So let me go through. This was a bit hurry as due to the time constraint. So the system registration usually takes place in parallel in different sections of the transmission network. You can see some substations which is highlighted in light blue, which are restored from Mahavali complex as a one part section of the network. Then substations highlighted in light green are energized from the Lakshapana complex in parallel, and substations in southern network, which is highlighted in the pink, is energized from the Samanala generators, and the substations here mentioned in this light brown energized from the Kukule, and similarly from Kalanithi small gas turbines, Kalambusiri supply, small part of the Kalambusiri supply is restored in parallel. All these are energized in parallel to save the time. So what we have done after the total failure occurred in August 2017, which took around 7 hours to restore, we have actually done restoration trials in different networks, for mainly for Lakshapana, Mahavali, and Samanala weather systems, and we have successfully tested the line charging capabilities of those generators, and we have derived and drafted the procedures in details such that operators can easily go through that during the registration process. And similarly, we have carried out the auxiliary supply restoration to the Lakvijaya power plant from Upper Kothmale via Kothmale, which was a bit controversial during the last registration. So some lessons we learned from the registration trials, which we directly used during the last registration, and as a result, we could save around 1.5 hours respect to the last failure registration in 2020. Synchronize multiple generators to improve the system inertia as quickly as possible during the initial phase of the registration, that to improve the inertia of the system being restored. And what we usually do is start a generator when at a load, energizing a 30 kV feeder. That has to be done carefully, because when we adding the load, if it is too much, then frequency response, drops significantly, and if generator cannot tolerate that frequency, tripped again. To avoid that one, we came to some norm that the step load we added to the generator at the initial phase shall be limited to 5% of the rated capacity of that particular generator or the isolated system. So it worked well in this case. Then addition of loads shall be done at least at a minimum interval of 1 minute to allowing some time to stable the frequency. Before adding any load, since frequency is going down during the load addition, generally we raise the frequency to a little bit high. Then some generator characteristic changes, technical characteristic changes we have been identified during the registration process. Accordingly, group setting of Navlakshapana at isolated network port has been changed to 4%. So those are the findings. And then when we observe frequency oscillation during the registration, the governors of that oscillated machines have to be put into the manual mode. So operators are well aware on those things after carrying out the registration trials. So what mistakes happened in the 2020, we took corrective actions, and that was implemented very successfully during this time. So this is how we restored the system. Initially, Mahavali system started to restore. Then actually Kothmale system registration get delayed because of energization delay due to the Kothmale Biagama 2 lines. Then what we went to the Victoria We energized Rantambi Ampar substations initially. Then we, after recovering the two transmission lines, Kotmale Gama, we restored the Kotmale. Then we synchronized that at 15 hours, the load of two systems at that time, this one. Then at the same time, Kalnithis, from the Kalnithis small generators, that Columbus supply is being restored, and that is synchronized with this system where the Kalnithis interbus transformers at 1535. The load of that time, Mahavali was 170, Kalnithis was 20 megawatt. Then Lakshapana system was restoring in parallel to these incidents. And Lakshapana and Mahavali system, or Lakshapana and the rest of the system is synchronized at 1603 hours. But at that time, the Lakshapana generation was 65 and Mahavali or rest of the system load is 240. Then Upper Kotmale, from Upper Kotmale, we are extending the supply to the Lakvija via the Nivanrathpura. So that system was synchronized with the rest of the system at 1607. Southern system at that time, I mean, during the last research process, we are unable to restore the southern system successfully because the frequent failure of tripping of the summer level generation. So it is not being restored as an island system. We restored that part by connecting the southern system with the Lakshapana system. Then finally, from the Kukule power generation, the Matugama and Ambalangadu, those substations are being restored in parallel. So it is synchronized with the rest of the system at 1635 hours from Matugama to Horna transmission line. That's how we restore the system in parallel. So once we connect all these systems together, the total load was somewhere around 900 megawatt. Then we gradually build up, restore, energize all the feeders. And by this time, almost all the substations are energized. Then all the feeders are energized and load increase as you have seen previously in the load curve. So that's about the restoration process actually. So these are some critical transmission lines which we need badly to avoid the future failures in case of transmission constraints. They are in pipeline. The Kotmale, New Polpiti, Hambantota 220 kV double circuit line. Kotmale, Kirindivala, Paduka 220 kV double circuit, then Paduka Horna 1C2 kV, and Kirdivala Veyangoda. So those transmission lines are to be implemented as much as possible to avoid any failures in future. But one thing I have to say, in the fly, it says to actions to avoid blackouts. As an operator, we can't say, we cannot say, we have to try our best to avoid the failures, but we can't have a system 100% without blackouts because there may be failures in the system. So protection schemes activates to protect our transmission lines to generators from the failures. So as a result of that, there are chances in case of severe faults to occur the blackouts. So however, we should take our every possible measures to avoid or minimize the blackouts in future. Thank you.
Thank you, Engineer Vetasinghe and Engineer Kudaheva. Now it's your time. So you can raise your questions. Those who are present physically in the ISL, they can raise your hands. And those who are joining remotely, they can put their questions into the chat box. I would like to invite Professor Engineer Janaka Ekanayaka, Professor in Electrical and Electronics Engineering, University of Peradeniya, to moderate the question and answer session. At the same time, I would like to invite the ministry appointed committee and also two engineers from the CEB to take seats in the stage. I think Dr. Tilak Siyambalapitiya will be joining. He is not in the country. He will be joining online for the question and answer session. Thank you.
afternoon, everybody. First of all, let me thank the ISL for entrusted me this particular job. And I also am very happy to see that this is happening, because I was in previous 2 occasions, I was in ministry appointed committees to look into the power failures. And my impression about the ministry was these reports always go to a bin, nothing happens. But this time, I'm so glad that the ministry, the committee, the ISL, and the CEB has taken steps to proactively see what we can do to minimize, as Aranda very correctly said, minimize these kind of events. Before I proceed with the questions, I saw a big mistake in one of the slides. I think, Aranda, if you can correct that. That was the slide where you were showing the power swing. The units on the x-axis was wrong. So y-axis was wrong. If you can correct that, it cannot be 40,000 megawatts. So it is kilowatt. Those who have seen that slide before, please remember that it's not megawatt, it's kilowatts. Right. So let me first invite the audience. If you could raise your hands, we can already see some on the chat box. There's some questions, but let me first give the opportunity to the audience to raise any of your questions, please. Any questions from the audience, please? In absence, let me, like while the audience gathering the questions, let me start from the. Yeah.
First of all, let me extend my congratulations for organizing this event today. It's very enlightening to, I think, to the audience present here and those who are in online as well, to see, to know what exactly happened on 3rd December on this total failure. I think we should be happy about the ministry taking initiatives to have an independent committee to look into this and to come with the truth behind this episode, and also CEB's internal investigations, and finally coming out with a report and presenting to all of us today for the enlightenment of the audiences connected with this seminar today. So it's very interesting, and I went through the total report as well, shared by the committee, and also the responses by the CEB as well. So those are very professional analysis, and a lot of technicalities went in. So I think we should congratulate the committee who spent so much of time on deriving this report, as well as the CEB teams and the CEB comments, especially to avoid such kind of incidences in the future. I think that's very important. There are 2 main important things for me. One is how it happened, whether there is sabotage, and also the second one is how to avoid such incidents in the future. I think both have been addressed, but I have a question. It is not exactly addressed. Whether the feeder 2 of this Biakama-Kotmale line was stripped due to earthfall, that is true, but it was not exactly clearly mentioned whether it was a sabotage or not, whether that kind of fall, that kind of earthfall can be created artificially by human intervention. But I think Mr. Vetasingh has said 95% of the transmission trippings, the cause is not really found. That is the normal nature of transmission trippings. So this also could be in that particular category of 95%. So can the committee or whoever can eliminate whether there is no sabotage at all or any indication to sabotage. Because as a layman, not as a person from the CEB, as a layman, the people interested, who is interested is whether there was any sabotage. The follow-up actions, there were weak points in the systems and various things, protection settings, why the other circuit tripped and the fault 85 limitations, all true. But the interest for the public, interest for the decision makers of this country is whether there was any sign of sabotage in this. But when Mr. Vetasinghe presented, he clearly presented that how it happened and how this fault was happened, and 95% of the incidents previously was also similar. There was no real reason for this particular kind of earth fault. So I think that particular point is not really addressed by the today. So I think that is the most important part, interest for the audience, I think. So if you can enlighten, perhaps the chairman or anybody else can enlighten on that further, I think it would be beneficial. Thank you very much.
Yeah, thank you very much for bringing up that question. That's a very valid question. In fact, the primary cause, how the fault happened, the high impedance fault, we are not sure. That's why we have stated in the conclusion, it's not conclusive. And also we found that this N-fold protection operating, now with the evidences that the CEB has produced to the committee, we can accept that such a thing can happen. Okay. And both are, as you correct, and as Mr. Vetasinghe presented, 95% of these kind of earth faults can happen and they are non-persisting as well. That's why you could energize the line. But if you take the two together, that means earth fault happening and that triggering the N-fold operation. If somebody knew in advance, if this sequence can happen, then that particular person may be within the organization or maybe outside the organization, whoever, if that earth fault is triggered, then this sequence can happen. That's why in our first recommendation, we recommend to have the law enforcement make use of the law of the country and find out, because that is beyond the scope of the committee, because we cannot investigate, in other words, so we cannot interrogate people to find out that. Am I clear? Or yeah.
The fault itself. So because of the fault and fault protection and all these things, those are second things. But the fault itself, can it be created by a human intervention? Because otherwise the fault may not come for years.
Yeah, I think you are putting a difficult question, because humans can do anything. Okay, so that is something that the committee cannot really tell, but I'm sure the members can tell. I mean, you know, like 95% of the cases, the data were only from Sri Lanka. We haven't done any global studies because other utilities are also doing similar studies. So this 95% came from our own records. Whether we had put enough interest to analyze the previous faults in the similar manner as we have been doing this time, we are not sure. So there is this 95% is out of the question in my opinion, because we need to do a global analysis to see in other countries how much faults, similar faults have been actually identified. That we haven't, I don't think I was listening to today as well as in the previous occasion, Mr. Vetasinghe has shown the data from Sri Lanka only. So I think that particular question is slightly beyond us, but I'm sure committee has their own opinion.
Thank you. I think we are putting too much focus on the most unimportant thing in the whole scheme of things, because nobody has suggested, including the committee, somebody has created an earth fault, right? And we have said, I think even in our interim report and also in the final report, that the indications of the fault from the relay records as well as disturbance recorder reports are consistent with a high impedance single line earth fault, right? Having said that, as Professor said, single line faults are, I think 80% even more, you cannot find a cause, right? It is the case here also. I mean, okay, somebody said there was a fire lit under the tower, somebody had interviewed an old woman who said, it was done. But we were not concerned about that. We just accepted that there had been some fault which triggered differential protection on phase B of line 2. There is no issue there. But what happened after that is the real problem, right? Why did end-fault protection activate? Because if line protection has operated, end-fault protection should have been inhibited. It cannot operate in theory, right? Now, I think I take this opportunity to throw in a different perspective. If you look at the CEB's protection system, transmission protection system, we have probably one of the best protector systems in the world. We have the best equipment sourced from top manufacturers in the world, and we have well-trained engineers. We have all that. I can't imagine a better system that we could have. Yet, if you look at some of the recent failures, including the 2020 August failure, right? What has really happened? Okay, you can go through the analysis, what happened, after the initial incident, but what has really happened is the protection system, reliable as it is. Remember, it is redundant. Now, if you take this Kodmale-Biagama line, there are 2 relays from 2 different manufacturers duplicating all protection functions, right? That is the level of redundancy that we have in our system. It is the case in all other lines also, right? So with all that, if you look at what happened in 2020 August and November 29th and December 3rd, what had really happened was there was an initiating event that would have been really unimportant in the whole scheme of things. But the protection system has failed to operate as expected. Now, whose fault that is, I think, is a discussion that I think we should differ, right? But the fact remains that now I think even the 2020 August failure, what happened there? Okay, somebody operated, okay, there was a 3-phase fault, 3-phase plant fault, right? If the relay operated within the 80 millisecond, interval, right? None of the other things would have happened, right? The fault would have got isolated and nothing would happen. If you look at that, relay took what, 156 milliseconds to operate, 58 or 56, right? It was between 80 and 158, all that took place. Not actually trip, everything that you can go into. There's a big report, I think Professor was also there, and that is what happened. So having the best protection system is not enough, unfortunately. And having the best trained engineers is also not enough. But every time there's something happen, and then even in the case of 2020 August failure, later we found out that this particular relay at Kerala Pitia also had faulty wiring, which never came out in any of the reports. So here again, end-fault protection triggered. If that didn't happen, we would not be discussing this today.
Interest of the time. Thanks. I mean, same question was here from somebody called Jagat. The blackout was happened due to 3 main reasons: the incorrect earth fault settings, incorrect end fault protection wiring, November 29 trip incident, paid less attention. Why CEB should not taken care those in early stages, as it eventually cost millions of rupees lost to Sri Lankan economy? Any response?
not take care those in early stages for protection, correct earthfall settings, and then not paying attention to the
with regard to incorrect setting, so the question raised by Mr. Jagat with regard to incorrect setting, I think we have during our presentation we have explained that earthfall settings as per our standard settings we have implemented in 220 kV Viyagama-Kothmale line, and for the settings that we have adapted, the relay has properly operated and tripped the line in 22 seconds. So what we have what we have got to know during that process is that there was a unknown persistent high zero sequence current in the networks. Because of that reason, the relay got operated and tripped the line. So with regard to settings, we can explain that they were properly implemented and the relay has properly operated based on the settings implemented in the relay. So relay setting is like that. So with regard to endfall protection, that his question is that why CB could not have figure out that issue before 3rd December. So in reality, 29th December failure, we have been able to, 29th November failure, we have been able to collect relay information from the Kothmale end and Biyagama end, and found that there is an intertrip signal going from Biyagama to Kothmale. So after that, we went to Biyagama and collected the bus bar protection records as well. But while we are investigating and analyze those information, we could not, we needed some time for us to come to a conclusion and give the recommendation for maintenance staff to carry out that modification. So before that, the 3rd December failure happened. As Professor Nilantha told that in May 2021 also there was one operation of this endfall protection. That incident also when we went back and check what has happened in that incident, that relay tripping information has not properly recorded in the CB system of records, and protection branch was not aware that that type of relay has operated at Biyagama substation. So that because of that reason, the May 21 or May 17th incident also we were not informed properly. So only time, the first time that we were properly informed is on 29th November. So that was, we were attending to that failure analysis, but the final conclusion we could not do and do the corrective action.
Thank you very much, Mr. Vetasinghe. There's a question for Professor Nilantha. It's not very clear. This is from Sarath Vikramasuriya. You said services and expert in IT industry is required to know the exact cause of the earth fault, whether man-made, accidental or intentional, or an unavoidable in any power system. I'm not sure what the question is, but it's particularly addressed to Professor Nilantha, so that's why I picked it.
I think he's referring to the accessing of relays. That is where we need IT experts. I think I explained the scenario in the presentation also. We had a doubt because we could see level 1 access right person has logged in 7 times in within 1 minute at 8:33 on the 3rd of December. However, we got a response. Only thing is 1 day after we submitted the final report. So we presented the contents as we had derived by the time we wrote the report. So the OEM response came late. So that is about it.
Okay, so there's another question here. What is the reason to activate the protection through the circuit? It is running in healthy condition. This is from Anuruddha Duverachi. What is the reason to activate the protection though the circuit is running? I think that why in a healthy circuit the protection has been activated? That's the question.
But I think the question that they have raised is not very clear for us because what we understand is Biyagama Kotmale line. The questioner is saying that claiming that line was healthy, but we cannot accept as it is because there was a phase B to ground earth fault in that particular line 2. Biyagama Kotmale line 2 had a real earth phase to ground earth fault in the P phase. So for the question for that line cannot be entertained in that manner. But the same way, line 2 also, we can't say the line was very healthy because there was a persistent zero sequence current in line 1 as well. After tripping of line 2, when we measure the zero sequence current in that particular line, with respect to load current, around 5% is zero sequence current is observed in that line. So that means when the line current is about 1500 amperes, the earth fault zero sequence current of about 75 amperes is observed in that line. So both lines we can say perfectly healthy lines. There were some issues in the lines. That's why the protection system operated and got tripped the lines.
I think the one reason Kosal has elected me as the chair, he knows that I have to go to Kandy. So I will stop this within the time frame provided. So that's why I'm trying to, there is a couple of kind of questions as well as, not really questions, some insights from one of the former employees of CEB and presently one of our colleagues, Mr. Kamalnath Samarakon, engineer. What is the typical groups? No, there's so many questions. I will just, they are not real questions. How can there be a zero sequence current in a healthy transmission line? Then the other question is, statement that for a transmission fault found is not acceptable. There are ways to find the location of the fault. So I will not pass this question. These are more because we said that this is a knowledge sharing session. So I think these are the knowledge sharing points Kamalnath is sharing with us. So I just reading those. Let me also share another very important knowledge sharing statement by one of our the listener from Australia. I'm sure most of you don't know him, Mr. Ranjit Perra. He's telling this again, I'm not going to put it as a question. I'm not very much familiar with the operation of Sri Lankan power system, but I have a couple of questions. It is not practice of isn't it not the practice of CEB to conduct credible and non-credible dynamic analysis prior to the event? The second is, if they have done so, why aren't they identified this total system failure? What happens if you trip Kotmale to Anuradhapura circuit once you have that double circuit failure? Isn't that the system recovery after under frequency load shedding? Are you saying generator frequency protection are not coordinated with UFLS? Maybe Eranda, you can respond to some of the questions.
in case of the under frequency, I mean, what happens when we have an imbalance between the generation and supply, when frequency goes down, the usual practice is to arrest that frequency by using the primary regulation. But what we have experienced is our primary regulation is a bit slower than to recover our system frequency, because since our system is very small, our frequency changes are very fast. And usually in other countries where we have large systems, it takes some time to reduce or increase the frequency. So it has enough time to recover it from the primary regulation. But since we have a small system, our frequency changes very frequently and very quickly. So in that case, we have gone to option to recover the system under frequency conditions from under frequency load shedding. So they are definitely check the frequency and wait for some time, defined time delays, and it activate the protection relays. So altogether that process, the break operation takes somewhere around 30 to 50 milliseconds. And we wait at least 100 milliseconds, and the total delay is around 100 to 130 milliseconds. And soon after frequency reach particular set value, after 120 to 30 milliseconds, definitely protection under frequency relay will operate it, and it arrests the system. In this last case also, the total generation loss is from Mahavali, it is 36%. The under frequency scheme is set to reject. If all the stages are operated, it is set to reject around 40% from the demand. But in this case also, total load rejection is somewhere around 30 to 33%. So it has been operated as per the expectations, but since the amount of generation rejection is too high compared to our system, it cannot be arrested by the operation of under frequency.
Just another small point to be pointed out. Somebody is telling that the link provided by CEB is not working. So if the CEB can look into that, this is the link to the response to the ministry appointed committee report.
Janaka, this is Tilak Simbalapitiya. May I come in?
Tilak, give me a second. Okay, just can you hear me?
Yes, I can hear you very well.
Just give me a second. I'll just trying to point out one thing here. And also this is the first time I think we are going to see 3 reports. One is from the ministry appointed committee and the response from the CEB, and I was told that the PUCSL report is about to come out. So this is a very healthy scenario. So I will pass the mic to Tilak, who is always been a healthy contributor to the power system of Sri Lanka. Tilak, over to you.
Yes, I will quickly focus on a few items since I am joining remotely. The question from Ranjit Pereira also included a part about modeling, whether modeling is not conducted and whether such situations are not foreseen. So we in the investigation committee conducted our own steady state modeling and found out that given the fact that the entire interconnection from Kotmale to Biagama was lost, and the reasons we have discussed, and even if the Kotmale Anuradhapura lines were healthy, the system would not be stable even in a steady state situation. So therefore, we have to remember that Sri Lanka was already running with a fuel supply constraint by this time, and hydro max scenario was the relevant scenario, and a lot of power had to be transferred from the central province to the western parts of the country. So what we lost is the most important link in the system. So even on a steady state, it was not converging, and this what happened as a result of many things was inevitable. But what we realized is that the dynamic modeling, so even if the system had an opportunity to stabilize halfway through, the dynamic modeling capability of CEB is still not complete. So for that reason, we did not do any dynamic modeling. The shortcomings are related to the confirmation of parameters of the system, the various transient parameters that are required to do a reliable modeling of the system. Now that I'm on this, let me focus on one more item, which possibly was not adequately discussed here owing to lack of time, I know. The Lakvijaya power plant trippings and why it takes 3-4 days to bring it back. We have made specific recommendations, have had a lot of discussions with the power plant management as well. So our recommendation was to resolve the absence of auxiliary power issue at the Lakvijaya power plant, so that the very large economic losses that happens when the power plant goes down for 4 days, which could also include load shedding as well in a severely constrained situation, should be quickly addressed and resolved. Finally, just to reiterate, there were 2 comments. One is the link is not working to get the reports. I can suggest to IESL to provide the reports on the IESL website. The reports are available. Maybe there is some difficulty. There are 2 reports that should be provided. Then, of course, there was another request whether the recording can be available. I'm sure IESL will fairly quickly upload the recording of this discussion into the IESL website, which is the usual practice. Thank you very much.
I don't know whether Nauman you wanted to respond to the comment about the Lakvijaya, the auxiliary power.
Yeah, auxiliary power. Actually, we have tried debate so many attempts, and just before the failure, we had successfully completed a trial operation where we brought power from Upper Kothmale up to Lakvijaya to restore the auxiliaries. But unfortunately, during this failure, it was proven that the time period taken to bring power from Upper Kothmale was beyond the time expected where Lakvijaya needed the auxiliary power. We had done it in about 1.5 hours during our trial, but during the failure, we found that that was not quick enough. So in the meanwhile, we are looking at other alternate options also.
Any questions from the audience? There are a few more here, but I'm going to skip some of them. Any questions from the audience? Yeah.
Good evening. So could you explain what is the present status of the minister appointed committee, present progress of the minister, because it says the earlier crisis of the 2020 is not, recommendation is not implemented. So due to that could be occur at the 3rd of December. And what is the present progress of the committee recommendation?
Yeah, that's right. Now, it's like this now. Once we submitted the final report, we are supposed to meet again in 3 months' time. That is from the 21st February, 3 months' time. We will have a progress meeting with the CEB in the ministry to see how far they have implemented the recommendation. That's how we proceed. Thank you.
Now, this is for the IESL committee. There are some questions which are not really, can be answered in a short manner like this. So it's better if you can share these comments and questions with the members of the panel and get their responses and publish them. That would be useful. There's some of the questions are not really clear. That's why I'm not picking them. Yeah, this is another, I think this was a rumor which happened. This is nothing to do with today, but it's good if somebody can clear this. is there another breakdown in one of the power plant at Noracholi power plant? Noracholi. So if somebody can clear that or give some insight would be useful. Now, Mani, again, over to you.
Yeah, actually, it's not another breakdown. Norachole plant has been running continuously non-stop for over 3 months now. And it's usual that we stop the plant to attend to normal routine maintenance. So this is such an instance where some urgent maintenance activities have to take place. There are some high vibration in some of the motors. So this has to be done. Thermal plants can't run continuously for 3-4 months without routine maintenances. So it's just a maintenance activity.
Thank you. Again, over to audience. We will run for another 5 minutes and close the session. So over to audience, please. So let me pass the mic to Susanta. He was trying to add something and
No, I think what I was trying to ask was asked by another person on the web. My question was exactly what he asked. How can there be a current on the neutral, secondary side neutral sequence current when the system is operating in steady state, unless there's an instrument error? Because you can't have a proportionate current, when the load current increases in the steady state, right? If there's a loss of line like that happened in when you lost phase B, yes, that can happen. That's a false situation. But in steady state, I don't know. I don't understand because I'm not a production expert. I have been reminded of that so many times. but from what little I know, I can't explain why there can be a neutral current, zero sequence current on the secondary side. I think that was raised by one other person. So that yeah, because that is why we still don't have a proper explanation other than this reset value at this simulation. Other than that, we could not find any explanation for line 1 tripping after line 2 had fully isolated, right? It went through the whole sequence. Yes, end fault operated. It locked out BCM side. All that is true, right? If that didn't happen, yes, so much the better. But even after line 2 was fully isolated and line was operating in N-1 reliability, carrying the full load without any problem for 23 seconds. 23 seconds is the lifetime, right? In power system terms. After 23 seconds, it's tripped, right? Because there was an earth fault indication. It can't be the same earth fault that tripped line 2 because that was fully isolated. So the explanation was it didn't reset after the current came down from the threshold value. Still, it didn't reset because of this erroneous reset configuration. Right now, that I don't know, but I think that is the only explanation we could find.
Shavi, the comment is this is a very healthy start to take voluminous reports prepared earlier, but never scrutinized by an intelligent audience. I suggest we continue this discussion led by ISL, perhaps with more time to take up detailed question and give adequate time for all concerned to give detailed answers. I think that's a very important suggestion. So we will take that on board, Shavi, and I'm sorry, I'm going to move on to the last. It's there in many places people are talking about the dynamic model. Why we are not having an accurate dynamic model and why we are not running it. So let me ask Eranga to comment about that to conclude the session.
Actually, to simulate that dynamic conditions, we are using the PSSC tool. So it need models which respond to the dynamic behavior of the system. Right now, CB have some models to simulate the dynamic conditions, but there are so it needs large number of data to get the perfect results. But we have some certain data, but there are not 100% precise data. Still, we run the dynamic simulation and we got some results, and we run the system based on them. We do some analysis and we came to some conclusions based on that. Those are fairly, we got some satisfactory results, but to do fine simulations or fine results, we need to have more data. So a few years back, various committees or various consultants have done tests to identify the dynamic data which require to perform the dynamic simulations. But 100% data we have not able to gathered yet. So it is in the process of the deriving the dynamic data based on the results test that we have done in earlier. So it is in ongoing process and it will be completed within the next few months.
Okay, thank it's probably it's good time to conclude the session. So I think this is as I said at the beginning also, this is a very healthy initiative ISL has taken. We all engineers learn from mistakes. I mean, without mistakes, obviously we cannot learn. So the mistakes are one important component of our learning cycle. However, this kind of, the dialogue never happened as far as I know. I was involved in three times in 2016 in committees, but never happened like this. So I must congratulate the ISL team led by Kosala and the Kamal for organizing this. And also we must congratulate the ministry appointed committee for pointing out this as a recommendation and the very positive participation and the comments by the CB members. So with that, let me conclude this session and thank you very much for everything.
Members, we have come to the end of the session. So I would like to take this opportunity to thank the ministry, secretary to the Ministry of Power and the former secretary to the Ministry of Power, Ms. Vasantha Perera, and all officials of the ministry and the ministry appointed committee for inviting ISL to host this seminar to share the knowledge among engineering community. It's a great initiative. Thank you very much. Again, I would like to thank the chairman and all the committee members and also the officials from the ministry for taking your valuable time and be with us here and sharing your knowledge with our team members. Also, I would like to thank Engineer Vettasinghe and Engineer Kudaheva for making us aware of the technical issues linked with these two failures and measures to avoid such situations in future. Further, I would like to take this opportunity to specially thank our moderator, Professor Janaka Ekanayaka, taking his time to be with us despite of your busy schedules. Thank you, Professor Ekanayaka. Also, I would like to thank all the invitees of CB, including Acting General Manager, Dr. Abesekara, and invitees of Public PUCSL, Lanka Electricity Corporation, so LECO, and council members for participating in this, taking your time to participate in this event. Finally, my thanks goes to ISL staff and also the Electrical and Electronics Engineering Sectional Committee for making arrangement for this event, Thank you very much. Wish you a pleasant evening.